Okay, so it is my big pleasure to introduce Alessandro Bonatti, who will be presenting a paper on data competition in digital platforms. Alessandro is an associate professor at MIT in Applied Economics Group. He's been there for a while after getting his PhD in economics from Yale. And he has been doing great work on dynamic incentives, on apologies, on dynamic incentives and on information in online markets. So in this, he's done a lot of, provided a lot of important contributions in those fields, as published in many papers in top journals. So I'm very excited that he's taking on the data questions in his research, and I'm looking forward to learning, more new insights from this talk. So now, Alessandro, you will have 40 to 45 minutes. I will be keeping track, and I will be monitoring chat for questions. After which the discussion will have 5 minutes, and the rest we can spend discussing more generally. So, Alessandro, please take it away.
Well, thank you, Anna, for the over-the-top introduction, and thanks, Julian, for putting this together and inviting me. This is joint work with Dirk, who is in the audience somewhere. If you have questions at any point, you could put them in the chat, and maybe Dirk would chime in. But honestly, I prefer if you just unmuted yourselves and ask them directly. The project that I'm excited to present is obviously on the role of data in the internet economy and on large digital platforms. This is a very active area in IO, both theory and empirics. It's an active area of Dirk and my research agenda. This project is significantly early stage, right? So as a result, I may not have many answers to your question. I definitely do not have all the analytical results that I wish I did, but I'm very happy to share this with you. And a consequence of this caveat is that I owe a huge amount of thanks to Vasiliki, who's going to discuss it and who had to work with very limited time and material. The background for this project is, as you all know, the unprecedented collection and commercial use of individual data, largely by digital platforms in the US, but at least as much in China. At a broad level, large platforms promise to create more value by matching consumers and products and services, but also introduce the potential for the exploitation of consumer data in legal, illegal ways, contract-based leakages, or in the more canonical price discrimination sense. Where does this project fit in? It fits into a question that Dirk and I are really interested in, which is how do different modes of data governance affect the creation and distribution of surplus on these platforms? For today, I'll just be defining data governance as the mechanisms by which platformers are capable and allowed to collect and transfer consumer data. So take it as with a broad definition. The question is relevant for regulatory reasons. If you think about the GDPR and the California Privacy Rights Act, it's relevant for technological reasons, as we can integrate more sources of data. It's relevant for strategic reasons. If you think about Google's FLoC or federated learning-based proposal of preserving consumers' privacy, getting rid of cookies, and that type of research. Let me just say that in earlier work by Dirk, myself, as well as many others, we showed that a simple policy that assigns ownership and control rights to consumers over their data is insufficient to bring about the efficient allocation of consumer information online. Okay? So that kind of goes to show that this is a relevant question for economic theory as well. With that background, what we want to do today is provide a model of important parts of the internet economy with a few key features. One is that platforms monetize the data through ad auctions, which is by and large the modal way of making money based on consumers' data. and where different privacy regimes can be compared in the model sort of on a level playing field. The two key elements of the trade-offs, as you will see over and over again, are that owning superior information allows a platform to improve a match quality, but information also is going to create potential for a very realistic and particular form of price discrimination, which is product steering. Okay? No two consumers pay different prices from the same good, but different consumers might be shown different goods with different, say, markups. Okay? At the same time, we want to be mindful of the fact that the presence of direct sales channels, for example, online or offline as they may be, are going to serve as restraints for this form of price discrimination if there are sort of offers that all consumers can access. So these are the broad themes that we want to get out of a model of this sort. I know I have been vague at this level, but let me just place this incompletely in the literature. Okay, so if your paper is not up there, it's not a strategic choice on my part. You know, just let me know what we need to read. The common thread that we have with these data externalities in our earlier work is going to be that a consumer's decision to participate on a platform affects other consumers' outside options. Okay, so this was done in different formal ways by a bunch of different papers, but it's going to be still present. More directly, the paper is going to connect to papers on showrooming, like Julian and Cheng's, like Heskey's paper next, actually, and many others in the room. I didn't put down papers on information structures in auctions, including some by Dirk on nonlinear pricing, including some by me. But I will flag that while I won't have anything to say today about self-preferencing, I do think that the model is suitable to that analysis, and we're seeing a proliferation of papers looking at essentially Amazon on this lens, including 4 on the market this winter. Okay, so this is a very active area both for us and for others. All right, what's the model? Okay. We're going to consider a finite set of J differentiated product sellers who can each offer a product line, menu of different quality levels. They have a quadratic cost of producing quality. There's a unit mass of consumers. Each consumer has a type in Rj. So really each consumer's type theta is a vector where each element of the vector is the marginal utility of buying a product of quality Q from a given firm J. So that's where the differentiation is coming from. Today, though not in the, maybe I'll get to it at the end. A fraction lambda of these consumers who's going to use a digital platform, a fraction 1 minus lambda is going to buy off the platform. What does the platform do? Well, they run an ad auction. It's going to be a very simple second price auction to match each consumer to a single seller. And the remaining consumers, I'll probably have to say offline instead of off platform every time, but they just do not use the platform. It could be the website of each seller. Please, if you have questions on the setup or the connections, just ask. Okay, otherwise I'll keep going. Now,
what's the story with quality that sort of slipped in quickly? Like, was there something you talked about before? I think, was it quality?
I just want to allow these sellers to offer different product lines rather than a single good to capture the product steering phenomenon, by which I might want to discriminate in prices between you and me, not by charging us 2 and 3 for the same product, but by nudging us towards a higher or lower quality product that come at different prices. Okay, so that's where the thanks, Eski. So that's where the second degree price discrimination aspect is useful. Okay? We believe that's obviously interesting, but also a more realistic. No, I know, but also a more realistic version of surplus distribution, surplus extraction online. Okay. Now, the consumer's valuations, the Musa-Rosen theta in the theta times Q, those are going to be assumed for now independent across both consumers and firms with marginal distribution F. What about the information structure in this economy? The platform is going to know theta, whereas the consumer of the platform is not going to know everything about their own preferences. So that's why they might need the platform. they're going to observe an informative signal that I will not model. Rather, I will just tell them that a consumer is born with a posterior belief about their type, MIJ, that's the posterior mean that you have on your theta IJ. And these M's are distributed, again, independently with distribution G. Okay? So all that really matters for now is that a consumer is born with a vector of beliefs. Those beliefs are marginal distribution G. Of course, F is the distribution of the truth, so it's a mean preserving spread of G. Okay? And for now, we'll assume that have the same support so that our life is easier. So again, 1 minus lambda consumers, they're going to buy based on these M's. Lambda consumers are going to access the platform, and as I will tell you in a second, they're going to learn their type perfectly through information that the platform gives them. The platform tells me my type if I use it, and runs a second price auction for a single advertising sponsored product type of link. What does it mean to run a second price auction for advertising? Well, it means that each theta vector is a targeting category. Okay, so the sellers or advertisers can condition their bids on the true type of the consumer, or put differently, there's a different auction run on the complete information for each consumer type. Not only the bids can condition on the consumer's type, but also the offers and the prices that each consumer might receive by the winning bidder can be conditioned on the true type. Off the platform, I'm just going to have a simple classic diamond story, so might as well assume it now, but it would be easy to get it as part of a result, that consumers with beliefs M, they face search costs, they visit directly the seller that they think they have the highest value for. Okay. What's important here is that the platform is really useful in terms of telling us about our preferences and what we like and what we don't like. So I am going to shut down any experience good type of or inspection good type of element. So it's not like by visiting a seller, I can learn my type for that seller. I need the platform's data to refine my, my information. What's the timing? To be a little bit more formal and to capture the idea of automated bidding for online slots. First, the sellers are going to simultaneously set their off-platform menus. Okay, when I'm off the platform, I see a consumer coming. I don't know who they are. So I'm going to offer a Musa Rosen style quality schedule. Next, the platform is going to reveal the type of a consumer participating on the platform to all buyers and sellers. Sellers place their bids. The winning seller can then offer a single product of a given quality QJ at a given price PJ to the consumer of type theta that they just won the right to advertise to. Okay. Now, where do these two on and off platform worlds interact is that after receiving this offer and learning their type, the consumer can also turn around and buy off the platform from any seller. In equilibrium, they'll think about buying from the winning seller, but in principle, they're unrestricted from in that sense. Okay. So let me go PowerPoint for just 1 second. Yeah.
So they learn their theta. They don't stick with their M after.
Right. No. So exactly. Think of M, the theta as being the truth. So once I learn my theta, my earlier type is gone. Right. It's strictly more information.
Okay, but all I've seen really is one product offer, right?
Well, think about the size of a page on Amazon, okay, or on Google. I have a bunch of organic links and then other sponsor stuff, and I can learn about what I like. And in particular, there's one in the model here. There's one slot that has been paid for, and that I can click.
Okay.
But thank you for asking that, and it is important that part of what the platform is doing is directly telling me about my preferences. This is not by showing me a ski jacket and me then exploring and learning, figuring out my value. It's really, there's an organic part of the story. So here is a search pattern that can happen, just to clarify ideas. Here's a consumer at the top with beliefs M about their type. With probability 1 minus lambda exogenously for now, they're going to buy offline, say their highest belief is for firm 1. So they can either buy from the offline menu of firm 1. Let me denote that by a nonlinear tariff P1 node for offline of Q1 from firm 1, or they cannot buy, and that's pretty much it. But if instead they're in the Lambda group that uses the platform, they're going to learn their true theta. That's strictly more informative than M, so that's all that matters now. And they might find out that actually firm 2 is the one that they like the most, or either way, firm 2 won the auction. Of course, I'll tell you about that. And now the consumer can accept the spot offer that firm 2 is going to make them, P2 of theta 2, Q2 of theta 2, or they can buy nothing, or they can buy from the offline menu of, in fact, any firm, but presumably of firm 2. Now that they've learned that they would have made the wrong choice had they not visited the platform first, they can go to the own website of this reseller and see what they have there in stock. Of course, they're going to see more than one product there because they will be at this point indistinguishable from.
One thing that I didn't get, Alessandro, does the consumer, each consumer must buy only one unit?
Yes, think of Q as quality. Yes, they have unit demand.
Unit demand, okay.
Yes, and theta is the marginal value of quality. Yes. So it really looks like, absent the platform with complete information on the consumer side and no search frictions, it will be a model of competing nonlinear prices, but it's going to turn out to be slightly different with differentiated products and unit demand. All right, so this is what can happen. This is what the platforms, actually, let me stay on this picture for a little while longer. The platform can provide value by, telling me that I would have visited the wrong firm had I not tried with the platform first. It can also monetize because now firm 2 gets to learn my type after winning the auction and make me a spot offer. It's not quite take it or leave it because I can go and visit their own website, but they can make me a targeted offer. That's where the product steering component comes in. Okay, so let me talk through the main forces a little more. On the platform, each seller knows the consumer type. Conditional on winning the auction, there is no adverse selection there, so it's a result, but let me put it up there, that the high bidder is going to offer a single product of the socially efficient quality level. There's no reason to destroy surplus at that stage. Now, off the platform, each firm J is going to face a distribution of consumers, and those are the consumers that value J's product the most based on their M beliefs, but they don't know who's who, so they must elicit this private information. They're going to offer a tariff. Now, a natural candidate for this tariff would be the Musa-Rosen tariff for distribution G to the J, which is the distribution of the highest order statistic of M that you're going to face in equilibrium offline. Okay. But it's easy to see that sort of static and standard optimal Musa-Rosen menu is not going to be the optimal one because there is a shadow cost of providing information rents to the off-platform consumers, which is that you're creating an outside option for all of these consumers that you face on the platform after winning the auction for them, who then have the option of showrooming and learning about themselves on the platform, jumping off and buying somewhere else. And so the more quality you provide off the platform, the higher the information rents are, as in every standard model, but that also is going to make buying offline more attractive. So let me go a little more formally. There is no price discrimination, strictly speaking, or personalized pricing online. There is product steering where I see a different theta. In fact, I bid for a different theta, and if I win, I get to offer them a different product of a different Q, of course, at a different price. And with a continuum of consumers and regular distributions, no two types will get the same offer. Now, what's the showrooming constraint that I alluded to for the winning bidder is that if I am J and I win the auction for theta, the utility that I leave to consumer type theta, so theta Q minus P, well, that has to be more than whatever this consumer can get by buying from me offline. Okay? We'll construct an equilibrium where this is sufficient to guarantee that the consumer accepts this offer, but for sure it's necessary. Right? So at least this is a concern, a constraint on the consumer's choice. Then again, if off the platform I'm offering an incentive compatible menu, type theta, it would choose the offer, we report truthfully, would choose the offer for theta itself off the platform. So really, my problem resolves to making sure that each consumer theta prefers the offer that I make them, or the bundle that I offer them on the platform, to whatever they would buy with that type from me off the platform. So it's a point constraint. So let me write down the seller's best response problem and then jump to the results and show you some properties and some pictures. Now, remember that what I said, that at the first stage of the game, all sellers are setting their offline menus, qualities, and prices, right? And then the whole auction takes place. So having set a menu Q0 with associated rent U0, seller J is going to make the following profits after the auction on each type theta online. They're going to make the efficient surplus, which with the quadratic cost is theta squared over 2, minus the rent that they have to leave to this type. And again, the rent that they have to leave to a type on the platform is the same rent that that type would make off the platform. So it's U0 of theta J. As a result, it's a second price auction. Having set Q0 and U0 in the first stage, each seller J will bid exactly their profits on this type J, type by type. So to put it differently, the rent U that buyers can make thanks to their private information offline determine both the market shares online and through the bids, and also the platform's revenue online. Now, how would you solve for, say, a symmetric equilibrium in this model? It is pretty standard. I'm just going to write it out and then give you the results. Imagine that everybody else is offering the menu Q hat, U hat. Then for each theta J, I can define the cutoff type in terms of the valuation that this buyer will have for all the other firms that under my own menu Q0, U0 makes them indifferent. Okay? And then understand that my best response problem is to maximize my profits with respect to my offline quantity and utility, understanding that I'm going to bid my profits as at the top of the slide on both the offline and the online lambda 1 minus lambda types. And what I want to simply point out here is that this is a slightly weird but not that complicated looking screen problem where the rent that I give to each type enters in terms of reducing the prices offline, enters in reducing the prices I can charge online to avoid the showrooming behavior. It would also enter in the characterization of this X of theta market shares, but it's going to affect the what happens at the marginal auctions. But in the marginal auctions, I make no profits because I bid all my expected profits. So it's not as ugly as it looks. Okay. Now, what's the solution is that there exists a unique symmetric equilibrium. This equilibrium is entirely characterized by the offline quality schedules that get offered because the online ones are immediate. They are the efficient quality level and the price discount that guarantees that the consumer won't showroom. Okay. What is this quality level that gets offered in equilibrium offline? Well, it's either 0 or less than the efficient quality. We knew that from Musa Rosen. What is the optimal amount of the distortion? The optimal amount of the distortion says that for any dollar of utility that I offer to type theta offline, I have to give at least that to all the higher types. That's Meyerson, that's completely standard. And so that's the 1 minus lambda G to the J term. But because of the showrooming constraint, I also have to give that dollar of utility to all the higher types online. And so that's why you also have this lambda F term there. And you can already see that the higher the lambda, the larger the distortion. This is quality. What are prices? Well, the prices are going to be determined by the rent function, and the rent function, because of the showrooming constraint, is identical point-wise offline and offline. So what are some properties of this equilibrium? On the platform, sellers sell the efficient quality. They don't extract all the surplus. They have to offer a discount to the consumer. Off the platform, there's some inefficient matching because the consumer's information is not perfect, and there are distortions to the quality provision as in all monopoly models. Okay. There's a cost of off-platform sales, which is that to the extent to which U0 of theta is positive, then also U star of theta on the platform is going to be positive. That happens when that consumer is served offline. The last thing I've done here at the bottom of the slide is to rewrite the expression for the optimal quality offline to show you that it is two pieces that will be quite standard. The first two pieces would be the Musa-Rosen schedule if the offline world was all there is, minus a further distortion, which is increasing in lambda as the shadow cost of providing rent offline increases. So in the remaining time, let me just show you some properties and behavior of this model, and then sketch a couple of variations in terms of what could the platform do if it faced different data governance regimes. So this is just to recap. Quality online is the 45-degree line. Quality offline is severely distorted down from that efficient level, and it's 0 for many types. This is a comparison of the first best, which happens online, offline, and offline without an online platform, it would have been still distorted, but higher than that. Payments are correspondingly higher, right? It's true that I have to give a discount to the online buyers, but I'm giving them such a better product, theta by theta, that I can charge them more. Okay? So here's how the quality and prices online and offline match up. Every theta, if they get to use the platform, which is exogenous for now, they receive a higher quality and they pay a higher price. That's sort of is intuitive and captures well the idea that the platform can make money by selling an efficient match to the seller, selling information about the consumer's type to the seller, and selling up to the showrooming constraint the right to basically be a monopolist vis-a-vis the consumer. So there's a lot that the platform can make. What this picture does not fully capture is that buyers online actually get a discount because this is Q and P as a function of theta. But if I just plot the nonlinear tariffs, it's pretty clear that you get a discount online and it could not be anywhere else, right? It could not be anything else. If the same product Q that I buy online is available for a lower price offline, I'm just going to go jump and buy it. Okay, so this is a world with identical consumers in terms of their search behavior. They just differ in what they use. You can imagine making it richer and then introducing the need for price parity clauses or most favored nation clauses, and that are the object of a number of studies. Here, it's sort of endogenous that our Amazon here will not even need to impose that because the sellers themselves will offer discounts quality level by quality level to retain those consumers. I've hinted at some comparative statics. Q0, which is both the quality provision offline and a measure of the rents and the surplus that all consumers make, is decreasing in how many people use the platform. It's going to be nil for lambda sufficiently high, even less than 1. I'll show it to you in a second. It's less obvious as a function of J, but if lambda is small enough, or if F and G are similar, then it's also decreasing in J, with the intuition that, if you have a better selected consumer population, you want to distort more because you have more high types. That's sort of the intuition. Consumer surplus, I'll show you in picture, is decreasing in lambda both online and offline, and it's non-monotone in J. Again, for intuitive reasons, better through a picture. Okay, so let me close the model by computing all the surplus levels. All the pictures I will show you are for an example of this kind, where consumers' beliefs are uniform 0 to 1, and consumers' true types are a mean preserving spread of that. So they're a beta distribution with a density of this shape. Why the beta? Well, of course, because it's easy and tractable. The interpretation is that the true type of the consumer would be binary and be only 0 or 1. But even the platform doesn't have perfect information. It just has more information than the consumers themselves. And so the more mass the beta puts on the tails here, then the better the platform's information relative to the consumers. Okay, so let me start with the easy ones. Total surplus is increasing in J because more sellers are sort of more shots on goal, and so it's better. It's easier to have a higher match quality. Total surplus also increases as a function of lambda because more consumers migrate to the platform, and that's where they get the efficient offer. Okay, but this is slightly misleading in the sense that if I control for lambda by looking at the total surplus over lambda, then that's decreasing, because what's happening is that all of these consumers, all the consumers that remain offline are getting a worse product, okay? Because it is now more expensive to provide rents online. Okay. Consumer surplus as a function of the number of firms is going to be non-monotone. It's increasing early because the difference between having just one firm and two is huge in terms of the option value of finding my better match. But as that effect wanes, then my surplus is reduced by getting lower information rents, both online and offline. Okay, and it's unambiguously decreasing in lambda as the quality provision and therefore the rents that we make goes down. Okay, so this is the connection, even though the models are completely unrelated, with the work on data externalities that JP and Daron Ajemoglu and their co-authors and Dirk and I have been, I think, presenting for the last couple of years. The more consumers here join the platform, lambda exogenously, the lower the surplus of everybody is going to be, because in this bargaining game vis-a-vis the winning seller, each consumer's outside option has deteriorated. It has deteriorated because now it's more expensive to offer quality and utility offline, and therefore we're all facing worse offers online and higher prices online because it's easier to retain us on the platform. Okay, so again, the channel is very different from learning about my type from others, if you're familiar with all of those papers, but it is quite connected. Okay. Producer surplus, and I'm almost done. Producer surplus reflects a more complicated trade-off, right? Which is, on the one hand, when J goes up, overall producers get better matches, and so there's more value to be created and higher value consumers that each producer can access. But of course, it also intensifies competition, and these two effects interact in a rich way. I mean, I don't have a proof that this is the shape, but this is an illustration that emphasizes the presence of all these effects. Okay.
And Alessandro, you don't need to rush. You have 10 minutes.
No, I do want to talk about something else, but I'm also happy to leave time. Thank you. I'm also happy to leave time for questions. Okay. This is the last one. Producer surplus as a function of lambda. It just shows how sort of rich these interactions are. On the one hand, I face more consumers on the platform, but on the other hand, I have to bid for them. And I have a higher opportunity cost. And so I'm going to offer less rich menus offline. Producer surplus as a function of lambda only starts to pick up for very high values of lambda, for which the firm has completely given up on the offline channel. And therefore, it just benefits from having more consumers coming through to the platform. So the bottom line for maybe a policy type evaluation here is this slide. It's what is the platform's revenue as a function of the total surplus generated. Okay, it is increasing in lambda as the unit profit that each producer is going to make increases, and therefore the bids increase. Okay? And so this is true in general, of course, as lambda increases, the platform is larger, but also as a fraction of the total surplus generated. For lambda sufficiently high, the sellers give up on the offline market, and the platform starts to capture, in fact, a constant fraction of the total surplus. Furthermore, the picture on the right has lambda equal to 1 already. So as the number of firms increases and with a lambda high, that fraction of the surplus, as you would expect, is converging to 1 as competition intensifies. Right, so maybe it's not shocking, but as the platform grows large and sufficiently rich, then they are going to extract all the surplus.
So Alessandro,
yeah.
So it seems that the competition among firms doesn't really need not help. because they are competing to be the one matching with the consumer. So all the energy for competition goes toward revenue, the platform, right? And so, but in practice, I think places like Amazon displays multiple products. So that can create some competition. And maybe that's because the platform itself is competing against another platform. I don't know the exact story. I don't know what's driving this, but I mean, certainly, I mean, in practice, you do seem to see multiple products displayed, and that can lead to competition for the same data. No?
Absolutely. So, what the picture here, of course, one here is a consequence of exactly what you've captured. The message here is to the extent to which a platform controls the availability of, reduces search costs, provides information, makes it easier for me to access a product, and reduces supply relative to, a benchmark where everything will be freely available, then these, the effects are all going to go in this direction. Of course, you're completely correct that there are many reasons why you're not just going to have competition for the market being the consumer, but also competition for access to the consumer, but also competition for the consumer's choice in practice with a longer listing. And that is, as you said, that reflects the fact that in practice, the platform cannot put a weight of -1 on the utility left to the consumer, but they have to put some weight on the utility that the consumer gets on the link, after seeing a link. And there are a couple of reasons for that. So one you mentioned is that there might be a competing platform. Another one might be that even the platform is not entirely sure of what the consumer tastes are. And so, one of the ways to create more value for the consumer is to actually, leave them more choice. Now, more choice is also going to, induce price competition, and that's both a realistic and a fun model to work with. But any reduction in supply, of course, is going to generate pictures with these forces. So to me, the question at this point is, okay, so now there are a number of initiatives being thrown out there by firms and volunteered by digital platforms to the regulators. There are initiatives provided by the legislator. Can we look at them, or a few of them at least, in the context of this type of model? And so in 5 minutes, let me just walk you through two very easy ones. One is, okay, what if we just do not allow the platform to use all the information that they have? Okay, so we limit their ability to, in this sense, indirectly resell the consumer's information. Okay, so this is essentially a comparative statics exercise. Let's just imagine that ads need to be contextual, or put differently, that the bids and the messages and the prices need to be measurable with respect to what the consumer can reveal by herself, not using what the platform knows in addition to that. Okay, so let's just use M and not theta. That's in the model. This is what we're saying. This means that matching is not going to be perfect. It's going to be slightly inefficient, just like the one offline was. There is still value for the platform because it can reveal the M to the winning bidder and generate efficient quality provision for that imperfect or noisy match. Okay. It also means that because the distribution of the M's is a contraction of the distribution of the F's, the sellers are in some sense less differentiated, and so they're going to bid away more of the profits. This is probably the best explained in Levin and Milgram's, I think it's AER Papers and Proceedings 2010. It's the conflation effect of, it's essentially bundling in auctions. Right? It's going to allow the platform to generate less revenue, but to extract a larger fraction of what they generate. And consistent with those types of intuitions, you can see that, at least in this picture, the unrestricted original blue model, where the auction is run theta by theta, does better than the model where the auction is run M by M for large J, for J equals 2 in this example. It would be better not to use the additional information. Okay? As the potential surplus becomes large because you have more and more J, it is better to run a more tailored or targeted auction. And the last bit that I want to talk you through is an intermediate step in between these two. This one says, suppose that the platform can commit to some form of fancy privacy scheme that is reminiscent of Google's federated learning of cohorts. Okay, so this is going to work as follows. The platform reveals with consumer eye anything it knows about their type, so the theta, but it doesn't tell theta to the bidders. It just gives a coarse message from a finite set to all the bidders, which consists of the ranking of the consumer's valuations. Okay? So it tells each bidder whether they're the high bidder, the first, second, third, for this highest value for this consumer. Now, what does this mean? That the efficient matching is guaranteed in the equilibrium of the auction. It also means that online consumers are going to have some private information because the winning seller knows that they're the high bidder, but it doesn't know exactly how high the consumer's theta is. Okay, so the winning seller is also going to offer a menu of products. Okay. So this has some a priori ambiguous effect. You have efficient matching, but you have distorted qualities online because now the online world looks more like Musa Rosen than it did before. And what we know is that under some conditions, such as the beta distributions, the unique symmetric equilibrium has the firms essentially giving up on price discrimination, offering the same identical schedule online and offline, which is nothing else than the Musa Rosen menu for the mixture of these two distributions that they face, the highest theta and the highest M. And that this quality schedule is going to slot right in between the efficient one, which is what we used to get online, and the super distorted one because of the opportunity cost that we used to get offline. Okay? So it's going to have an a priori ambiguous effect on consumer surplus. But what I think is more interesting, and I want to wrap it up after this, is that it can be quite good for the platform. Okay, so blue is theta, red is M, purple is the ranking. And what this shows is that for a large enough number of firms, revealing the ranking can be better than not using that theta at all. And for a large J, in fact, it's almost this more privacy preserving policy is almost as good as leveraging the entire information. Now, that's kind of easy to say because probably all of these revenues are converging for large J, but the ranking is...
Just for clarification, the ranking means that the ranking across different goods for each consumer, is that what you have?
Yes, so the platform tells the consumer the type precisely, but tells the firm whether they are the highest value, the second highest value, the third highest value. So there's one message that goes to the sellers for each ranking of the capital J firms. Okay, and you can think of a ranking as a cohort in my Google analogy.
Thank you.
So when you bid, you basically bid the expected profit with the equilibrium menu that you're going to offer under the distribution of the kth order statistic of the consumer's type, depending on what was the ranking that was announced. Okay, let me stop there because, as you can see, this is a lot of work in progress, and I think there's a lot to do. Just as one concluding thought, the growth of a platform's database influences the consumer's outside option. This can be viewed endogenously, can be viewed exogenously, but it's also a measure of differentiation of different platforms, right? In some cases and for some industries, very little happens in niche products off of Amazon. In other cases, you know, as Yonku was also saying, there are organic results and buying alternatives readily available. Yeah. So all of this is saying that I think we need a more complete picture of competition in product lines in the digital economy under alternative information structures and data governance regimes, which is what we're trying to do. Thank you.
Thank you, Alessandro. So our discussant is Vasiliki Skreta. She's a professor of economics at University of Texas at Austin. She's done a lot of work on auctions, on market design, and on informational issues, not only in online markets, but also in online markets. So Vasiliki, you have 5 minutes.
Was my screen sharing working?
Yes, we were seeing ourselves. Yeah.
Okay.
Now I think it's, now we see your screen, but your slides are a little bit sideways. I think now,
okay.
Yeah.
Now we're good. I think we're getting there. Okay. So now the screen is good, right? Well,
Yes.
Thanks a lot for the opportunity to discuss this very interesting work, which is part of a very deep and actually important agenda that Dirk and Alessandro have been developing. So I was thinking about this paper and doing some introspection, and I was thinking, how does a platform help me find a new bicycle? Which is true, actually, I want to buy a new bicycle. So when I go Google, Google owns Gmail, which I use, owns Google Maps. So they know the searches I do when I try to find directions. They know my gender, they know everything and more than I can imagine. So so they know a lot about me, but when I search the term bicycle, it really helps me find the bicycle that I would like the most. It actually teaches me about brands that I don't know, and maybe things that I would not have really figured out if Google was not there. So what does this paper do? They ask, how does data governance affect the surplus created and split among platform producers and consumers? So they investigate how these kind of different modes of data governance affect this distribution and creation. And there are trade-offs. The trade-off is efficient marching versus information rents. So the bulk of the analysis has been performed in a sort of a laissez-faire regime where there is no data governance, which in their model means that once you go to the platform, you learn your entire vector, theta ij. So you learn about your precise valuation about every available product, and that should be a J, not an L, sorry. And also that becomes public, so then there is no more asymmetric information, which means that firms were going to offer the efficient quality to each person, and they are going to extract all the surplus. And the surplus would have been zero if there was no outside market, but now there is also an outside market. So you can go to the platform, learn your theta, but then you can just go and buy the good from the individual website or from the store. So that's the key, the benchmark that Alessandro discussed. And then he contrasted at the end with a situation where we have a contextual regime. So now the ad is based only on the search query. So basically, when I look up the word bicycle, Google is going to show the same results to me and to my husband and to my friends, which means that they're not going to be targeted to my own tastes and needs or whatever. So that's going to lead to inefficient matching. And we're going to have the same offers on and off the platforms. So when we have a contextual regime, it's kind of more privacy preserving, but on the other hand, I will not be able to find those really niche bicycles that I would have loved to see if they were able to kind of do the search term based on me. And of course, there's an intermediate situation that Alessandro called the cohort-based ads, which in this case, the platform shares information, the vector theta I, with consumers, but not with advertisers. So now consumers do have information rents, which will result to some distortions on and off the platform, but it's going to be differential distortion depending on where you're buying the product, on and off the platform. So what are the key ingredients in their model? There's a monopolist platform. There are many sellers. There's a continuum of consumers, and consumers without the platform, they have an estimate about good J, which is private. With the platform, we have publicly revealed valuations. So now no information rent off the platform, but so the consumers are going to get on the platform this QP, which is their efficient quantity. And without outside option, their surplus would be zero. But with the outside option, they have the best outside option they have, but now they know the theta. So the platform really affects both outside options consumers face in the market. And there is a unique slot, and bidders bid for that unique slot, which in competition erodes their profits. And there is this key equation which determines the offline schedule. And as Alessandro was pointing out, the fact that the offline schedule affects outside options of consumers. So when the firms are choosing the quality schedule is different from the one we would get if we had, let's say, a single seller in a Musa-Rosen model. Then we would have this term roughly, and now we have an extra distortion, which comes from the fact that the rents are also used to determine profits on the platform. And these are the comparative statics Alessandro mentioned. Total surplus increases with a number of firms because we have better match, so I can find a better bicycle. Consumer surplus increases initially, but eventually too many firms lower information rents. Producer surplus is the opposite. So initially decreases and then it goes up, which is quite counterintuitive, I thought. And when we have endogenous participation, the platform becomes more valuable the more products there are, which is intuitive. So the equilibrium endogenous participation levels increase in the number of firms. And what are my comments? So this is a really very nice and tractable model that one can use to say a lot of very nice things, especially this. I like the fact that information and the platform really does affect consumer welfare, because really consumers get access to more products, which is, I think, true. And one comment I thought is that, from introspection again, there are many firms I don't know. There are many producers of bicycles that I don't know. And if I do a search on Google, I'll actually learn them. So this actually, maybe one could use this model to think about the entry of niche products. So suppose like I know the 2 or 3 sellers, REI or whatever, Academy, that sell bicycles, but then I don't know all these nice niche producers that I can find on the platform. And another thing that I thought that could be kind of tweaked a little bit is that instead of having the same support of the distributions of G and M, we could think that their MIJs are sort of buckets. So they are sort of like the off-road bikes and the street bikes, and they are kind of broad products that I kind of know without going on the platform. And then once I go on the platform and I do the search, I start to see the finer categories. So I think thinking about that could actually be just a way to reinterpret the model, or maybe could lead to some new analysis. And of course, one big thing is that maybe there is platform competition. What would that do in this world? I don't think it's a first order effect, but maybe it would be interesting to think about a little bit how platform competition could lead to a little bit more realistic predictions about how the surplus is split between the platform and sellers. And that was a question that Hesky asked early on. The interpretation of Q, what is Q? Is it the Adams thing? Is it the quality is it the type of product that is produced? What is exactly? So maybe a discussion about the interpretation of Q would be useful, I guess, in future stages of this project. But overall, it's a really very elegant and rich model. And it's really, the nice thing about the model is that it's tractable and you could say a lot of things. So I really enjoyed. Thanks for the opportunity.